Hi, Assalamualaikum. My name is Fatih Antira binti Muhammad Asri. My metric number is DE190050. We are from group 17. So today we would like to present our experiment 4 for subject BEJ20801. The title for our experiment is Introduction to Simulink. First of all, we would like to thank our lecturer, Prof. Madia IR Dr. T. Kian Sik, for helping us throughout the experiment. Next, I would like to introduce my team member. The first one is Betty Hoyoli. Her metric number is DE190076. Next, Muhammad Fikri Bomahili. His metric number is DE190037. And lastly, Muhammad Aizat bin Jafar. His metric number is CE2044.
Hi, my name is Nick Muhammad Aizat bin Jafar. My number 3 is CE200044. So today I want to show you about the part A tutorial exercise. So the tutorial is this link. So the exercise is Simulink basic tutorial. So at the first, how to starting the Simulink. The first step is we open the MATLAB and then we press home. To open the Simulink, we press this start Simulink, and then I follow the instruction. So the instruction is when you start the Simulink, bring up a single window, and we press the blank model. So we can create own model to run some block. So we follow the instruction. So we can create or modify for the run the Simulink. So for the simple this block, I will download this simple block file and how to open it. To open it, we just press this open, and then I just download it before, and we press it and then click open. So this block will appear, and then we can use it to run. For the basic element, there are two major classes of item of Simulink, block and line. For the block, there are several general class of block within the Simulink library. For the line, we can just we can just drag it to create the line. But line can never inject a signal into another line. This must combine through the use of blocks such as Simulink junction, like this. So for next step, that have some example that given. So I will create this block. We can delete this line, and then the simple model is how to modify the block. So how to modify is really easy. We can just double click at this to modify the numerator and denominator coefficient. And then how to change it, the denominator and numerator to s squared plus 2s plus 4. To change it, we double click and then we input uh, the what we want to input the equation. So I put the denominator is 1, 2, and 4. And then we press apply and OK. So the block we must drag and OK. So we will see the equation as we input that before. So we should reflect the change in the numerator of the transfer blocks. And then the step block can also be double clicked. So the step block, this we can also double click to change the block, the step time, initial value, final value, and sample time. And then how do we to run? And this for a scope, so we can see the graph when we run it. So as I asked before, how to run the Simulator. So how to run is just we can click run, and then when it's completely run, we can see uh, the graph clearly. And next step is rerun. The how to rerun the simulator, we can just press the Ctrl and T to rerun it. And then to modify the graph, we can just press modeling and press the model setting and then press model setting, and the configuration parameter will appear, so we can adjust start time, and solver detail to see the graph detail more. And then this is all from me. Thank
Hi, Assalamualaikum. My name is Fatih Atira binti Muhammad Asri. My metric number is DE190050. So today I will continue our presentation with part B, transfer function. As we can see from the lab sheet, they have been given the transfer function and we need to assume the value of M, C, and K. So first of all, we need to open the MATLAB program and click the Simulink. After click the Simulink, the Simulink start page will pop up and click the blend model. And in here at the blank space, double click and find a step. Transfer function and scope and connect it. So for this step, we choose our denominator value, which is 1, 5, and 60. Apply and OK. Okay. So click at the scope and click right. So at this scope will show us our waveform. So as we refer back to the lab sheets, it required us to find the maximum overshoot, rise time, and setting time. So to find those requirements, we need to type a few lines of program. One is the value for our numerator and continue with our denominator value, which is 1560. So this is our answer for overshoot, settling minimum and maximum, settling time, transient time, and rise time. So this is our waveform for those answer. So this is our peak value, rise time here, settling time. So that's all from us. Thank you.
Hi, my name is Betty Hoyutlay, metric number DE190076. I will continue to demonstrate for part B, which is the closed loop system with PID. Firstly, we need to create the block diagram. We click on library browser and select step first. Click on step. And then we click the next component, which is sum. The next one is gain. Next is the PID controller. Now we find transfer function. Select on the first one. We make this one bigger so that it can display our whole equation later. Then lastly, our scope. Select the first one. Okay, so now we connect all the blocks. The sum will be connected to the scope before the final output. Now we edit our sum. Double click and change the sign to negative for one of it. Click on apply and then click OK. Now we change the value of our gain to 5. Click apply and OK. For our transfer function, we will do for 1 over s squared plus 5s plus 60. Click apply and OK. So now you can see it's displaying here. Now we click on run. So we can view our scope now, double click. This is our output. It doesn't look quite good, so we need to tune it using the PID controller. Just click on tune. To tune it, we just need to adjust the scale of the real response time seconds and also the transient behavior. We can adjust it until we find the graph that we desire. Then click on update block. You can see that over here it stated updated. So we can close this window and then click OK here. Now we click on our scope and run again. So this is the response that we have obtained earlier from the tuning, but we can't see it clearly. But it's okay, we can click on zoom and select our desired area to zoom. Still not clear, but we can zoom again. So I think this is quite okay. This is our output scope. So that's all for part B. Thank you.
Hi, my name is Muhammad Fikri bin Muhili and my metric number is DE190037, and today I'm going to represent the conclusion for this lab. For 3.1 is a main finding. As a result for our lab experiment, we may infer that we understand how to solve and evaluate speed control. Aside from that, we were able to use Simulink to control a block diagram of control system and assess the feature of speed control system response. We were also able to use Simulink to design a control system block diagram and test the feature of transfer function response. Furthermore, throughout this laboratory session, we as a group should be able to display effective collaboration skill for contesting needed tasks. Finally, we learned the characteristic of a transfer function and create a sufficient block diagram to measure and calculate the transfer function response by using Simulink. Overall, by inserting the value of MC and K ratio, we can obtain different type of graph. Next is for the 3.2 is a recommendation for a future experiment. For future experiment, we hope the university teach more on how to do Simulink. One of the reason with the Simulink student can do their project assignment simulation by Simulink. Simulink also got a lot many tools that can be explored and can use depend on what their project is. Not just electrical tools, Simulink also provide a variety of engineering tools that can be used by students. Also, Simulink capable of do math problem and give output result graph is much more convenient for students. One of the main advantages of Simulink is the ability to model a non-linear system which a transfer function is unable to do. Another advantage of Simulink is the ability to take an initial condition. Finally, for 3.3 duty distribution among members. First is the Fatin Atira BTS3. She doing a part B transfer function and do question 2.1 and 2.2. Also, she doing a compiling video. Next is for BEJ20801. She aligned the organization and production of the experiment content and distribute it. And she also doing the question 2.3 and 2.4. Also, she doing a compiling report. And Muhammad Fikri, myself, is doing a part A tutorial exercise, which being given by the lab sheet, the link, and the question 1.1 and 1.2, and do a conclusion part. And last but not least, our friend is Nick Muhammad Aizad bin Jafar. He doing a part A tutorial exercise also. Do a question 1.3 and 1.4. Organize group meeting, place, time, date, member contact information, communication requirement, and timeline, and etc. So that's all for our group. Thank you for watching our video. Thank you.